Okay, now the main thing will be more in the next page. Okay. Just now I told you, you are interested to know the displacement, the velocity and acceleration of something that undergoes SHM, right? So the one that is the more important one for your current chapter is actually this one, the one on the next page. Okay. Now let's just consider the same mass on spring system that's displaced from equilibrium position and undergoes SHM. When it undergoes SHM, there are three positions that you're always interested in knowing. You're interested to know the equilibrium, you're interested to know the bottom and top position. Okay, you are interested to know what happens at these three specific points. Okay, now at these three different points, your acceleration and velocity could either be maximum or zero, but which is which? Now, the first thing that we will tell you is that when you are at the top and bottom position, your velocity will always be zero as your object moves up and down. Your velocity is always going to be zero at the amplitude, in other words, the top and bottom position, because the mass has to stop temporarily or momentarily before switching directions. Because you see, if your mass goes up and it wants to go right down, it has to stop temporarily here. The same could be said when your mass goes down and then it wants to go back up, it has to stop temporarily here, okay, at the amplitude position. So at the top and bottom positions, your velocity would always be zero, okay? That's one thing to note. So if you are going to have velocity being zero at the top and bottom position or at amplitude position, where would your velocity be maximum then? Your velocity would be maximum at equilibrium position. Okay, this is where your velocity is always going to be maximum. And bear in mind that when the velocity is maximum at equilibrium position, it can be in two different directions. In your case, for the mass spring system, you could have a maximum velocity upwards or maximum velocity downwards, because if you look at how your mass moves, it goes up and down, up and down, up and down, right? So if you're talking about equilibrium position being where your velocity is max, you see at this point here, your mass is actually moving downwards. And then at this point here, your mass is actually moving upwards. So both are considered to be maximum speed, but the direction is different. That's why we can say that your maximum speed could be directed upwards or downwards. Okay, but the magnitude is maximum there. Okay, now this one is just talking about the velocity. We move on to acceleration. Where will be the points where acceleration is maximum and where will be the points where acceleration is zero? Now, the easiest one to do would be when acceleration is zero. Acceleration will always be zero at equilibrium because your displacement is zero there. Remember just now I told you for simple harmonic motion, A is directly proportional to X. So if X is zero, A is zero. If X is max, A is max. So when you are at equilibrium position, your displacement is zero, your acceleration should be zero. Okay. At amplitude position is where your acceleration will be max, because here your displacement is max. Okay. So these points here where velocity and acceleration are zero and maximum, you need to remember them because a lot of your questions are based on that. All right, when you want to do the questions. Okay, now further to that, you need to know how to calculate velocity and acceleration at specific points. You look at the table in between the diagram and the notes here, we want to find out velocity at a point. The equation is v equals to plus minus omega square root of x naught square minus x squared. Okay, this one is for you to find velocity at any given point, or rather at any given displacement. All right. The reason why you have a positive and negative sign here was because you need to take into account that velocity can have two different directions, because in your case here, you can have something that moves up. You can also have something that moves down. Okay, so the positive and negative is actually to take into account the different directions. Okay. Now, if you want to find out maximum velocity, you can actually derive it from this first equation. Just now I told you that velocity generally would be maximum when your displacement is 0, right? So all you just need to do is you look at the first equation, you go and substitute x as equals to 0. Your entire expression will now simplify to Vmax equals to plus minus omega x naught. Okay, because if you do this, you're going to get plus minus omega x naught square, right? This one will become plus minus Vx naught. Okay, so this is velocity maximum. Again, you have positive, negative sign there to take into account that you could have two different directions when it comes to maximum speed. Okay, so this is for velocity. Now, next comes the part where you want to calculate out the acceleration at any given point or at any given displacement. This one will be a equals to negative omega square x. This one is actually your defining equation of SHM that I mentioned in the previous pages. Okay, so here, if you want to find out the maximum possible acceleration, the maximum possible acceleration usually occurs when your x is equals to your maximum displacement. Okay, when x is equals to your amplitude position. So all you just need to do is that your x, you equate it to x naught. X equated to x naught. You're going to get a max as negative omega square x naught. Okay, so these are how you find the values for your acceleration and velocity. You really just need to remember the first line of equations. From there, you can actually derive the second line quite easily. All right, all four needs to be remembered, but it will be easier to remember the first line and then derive the second line from that. Okay, now your questions a lot of time will ask you to plot certain graphs for simple harmonic motion. They will specifically ask you to plot velocity versus displacement and acceleration versus displacement. Okay, they don't ask you to plot velocity versus time or acceleration versus time. That one was what you usually draw in AS kinematics. Now here, we don't ask you to draw velocity versus time or acceleration versus time. We specifically want you to draw your acceleration and velocity with respect to displacement. Okay, so how do you go and draw the graphs for acceleration displacement? For example, this one is pretty straightforward. Just now here, you already learned that A is negative omega square x, isn't it? If you try to equate this to a straight line equation, you can see that the y-axis is A, the x-axis is x, and then your gradient would generally be negative omega square, right? Your gradient will be your negative omega square, isn't it? So here, what you can actually deduce is this. If you were to try to plot a graph, plotting a graph of A versus X gives a straight line through origin with negative gradient. Okay, if you were to compare your equation for acceleration with a straight line equation, this one will tell you that you should get a straight line through origin with negative gradient, which is what you're seeing right over here for acceleration versus displacement. Okay, so this is your acceleration displacement graph. Okay, now what about the case where you want to plot a velocity versus displacement graph? The equation that you learned from above was V is equals to plus minus omega x naught square minus x square, right? So this one, you see there's a square term, there's a square root term. This one, cannot be compared to a straight line equation. Okay, it will be some sort of curve. Okay, because there's a square term there, it will be some sort of curve instead. Okay, so how do you know how the shape should look like? You start off by plotting 4 significant points on the graph. Okay, what do we mean by the 4 significant points on the graph? Just now I mentioned to you this B is 0 at amplitude, B is max at equilibrium. Okay, these are one of the key takeoff points from the previous section. Velocity will always be 0 at amplitude. Velocity is max at equilibrium and can be opposite directions. Okay, either up or down, right? Isn't it? So here, what we want to do is this. At positive amplitude, V is 0. At negative amplitude, V is also 0. So plotting it on your graph would be these 2 points here. At positive amplitude, velocity is 0, and negative amplitude velocity is also 0. Then after that, P is max at equilibrium. What you can say is that at x equals to 0, P is equals to positive negative V max, which would be these 2 points here. At 0 displacement, you have positive V max and negative V max. These are what we mean by the 4 significant points. Now, once you have drawn out the 4 significant points, you just draw some sort of curve to join them. Okay. Now, depending on the scale of the graph in your question paper, it can be oval in shape or circle, depending on the graph scale. Sometimes you may get an oval shape, sometimes you may get a circle. All right. It really depends on the graph scale that's being given to you. Okay. So these are the 2 common graphs that you will be required to draw in your exam. Okay. Now, one thing I should also probably mention to you is this. You will notice that your equations that I've given you in the table here, you have positive, negative, and then you have negative signs, right? Usually, you can just omit out any negative sign if it concerns calculation of velocity and acceleration in your exam questions. If your exam question is asking you to calculate out your velocity and acceleration, you don't really need to bother so much about these signs that are at the front of your equation. Okay, you don't really need to bother about the negative specifically. You can just omit them out. You really only need to bother about your negative sign when it concerns graph plotting or definition questions. These are the only times where you need to be careful with your negative signs inside your equation. But for the purposes of calculation only, no need to. Okay, they really just want the magnitude. They don't really bother about whether you put any negative sign there or not. It is really only important for graph plotting or definition questions. Okay. Now, sometimes you may be asked to deduce from a given graph whether something is following simple harmonic motion. The statements that you're seeing here is actually talking about that. This one is deducing from graph whether something is simple harmonic motion. Okay. So from the graph, you're supposed to see this. If you're given an acceleration displacement graph, if you see that your graph is a straight line through origin, it indicates acceleration is directly proportional to displacement. And then if you see further that the graph has a negative gradient, it means to you acceleration and displacement are always in opposite directions. Okay. Later on, you will see in some of the questions when they give you a graph and they ask you to deduce whether that graph is indicating simple harmonic motion. You generally try to look at these two. See whether it's a straight line through origin, see whether it's a negative gradient. Because if you have straight line through origin, it tells you that acceleration is directly proportional to displacement. If you see a negative gradient, it means to you that acceleration and displacement are always in opposite direction. Okay,